All right, the last part of this video is going to be the application questions, which is to find the area under a function when areas need to be calculated. This is super, super common in the AP exam. In fact, this is probably the single um, most common type of question that you see in the free response section, where they give you the kind of graph you're going to be seeing in the section. So make sure you ask questions if you have them. Before we do this, just a quick reminder, you're going to be finding areas yourself, which means it's kind of good to be really quick with this. Area of a rectangle is base times height. Area of a triangle is 1/2 base times height. Area of a semicircle is, well, semi is half, so a circle is pi r squared, and that would be half of it, so I'm going to put a 1/2 pi r squared here. A quarter circle would be a 1/4 pi r squared. Sometimes you'll see those too. And then a trapezoid, I'll be honest, I tend not to use trapezoids, but I know a lot of people do. A trapezoid is 1/2 times the height times base 1 plus base 2. And I'm going to draw a quick picture of how they usually look in these problems. Usually you have something that looks like this, like a space that looks like that. And if you're looking at that, the bases are actually the sides here. So this is like a trapezoid on its side. So this would be base 1, this would be base 2, and then the height is the distance between them. So if you find yourself wanting to use trapezoids, great, go for it. The reason I tend not to use them is that if you break it up right there, now it's a rectangle and a triangle. And for me, I'm just always faster with rectangles and triangles than I am with trapezoids. But it's totally up to you. Here is the problem that you've been asked, or that you see. Notice that we've got several sections that are below and this one big section that's above. There's a whole bunch of questions about integral from -5 to -3 and so on. Basically, we're going to need to know the area of all of this. So I've got another slide where I'm going to do all my scratch work. Let's start with this. This area below right here is a rectangle. And you can hopefully see that this is 2 by 2. So 2 times 2 is 4. So this area is 4. This next little piece, I'm going to switch colors a lot. This next little piece is a triangle. The base of that triangle is just a half. It's 0.5. And the height is 2. So if you do 0.5 times 2 times a half, you get 0.5. I know this is small and annoying, but this is kind of what these problems are like. One thing that's nice about this, though, is, hey, this is the exact same triangle, right? You should look for things that make your life easier. So if that's 0.5, then this is also 0.5. Moving along, the next area is going to be, you could do this as a trapezoid if you wanted, but I'm going to do this one big rectangle. You notice I didn't quite go to the edge there because I want to keep it all on boxes. Here's a rectangle that is 2 by 5, so that area is a total of 10. As annoying as this is, you don't always have to do all of it. Since I wrote this problem, I know I asked you to do everything here, but normally I would pick and choose and only do what I need to do. Next area, if I go up a little bit here, I've got this triangle. This is a long, skinny triangle, but I can see the base and the height. The base is 5, the height is 1, so the area would be 1/2 times 5 times 1. So the area of this long, skinny triangle is 2.5. Almost done. We've got this triangle here, and even like looking at it a little bit, I can see that this triangle is the same as that one, so I'm not going to have to do this twice. This area is 1 times 3 times a half, so that's going to be 1.5, and then this will also be 1.5. You're going to notice you get a lot of 0.5s in this because of the 1/2 with triangles. There's no circles in this example, or semi or quarter circles, but all you need to know for those is the radius. I'm gonna come back here, but go back to a blank one too. So the first question is the integral from -3, or I'm sorry, from -5 to -3. So that would be from here to here. This is kind of easy. We found it earlier. That was just 4. So this integral is just 4. The second example, whoops. Sorry, I meant to erase that. The second example is the integral from -3 to -2. Well, this area is negative and that area is positive. We found them earlier, but since they only asked me this little thing, you should notice that they're the exact same and so they cancel out. We didn't actually need to do work for that at all. I just wanted to show you how it would be done. Moving on. The next area that they ask for is from -2 to +5. So that's here's -2. And then +1, 2, 3, 4, 5 is right here. So I need all this area. I'm going to erase all this in a second. But I want to make my life easier. So I remember that those were the same, so they're going to cancel out. I really only need to worry about the rectangle and the triangle that I did here. So I'll go back one page. That was 10 and 2.5 together. So this area is 12.5. Again, with the knowledge that those cancel out. And then finally, our last integral that they asked for here was from 5 to -5. So here's 5, here's -5, and I noticed that they're going backwards. So, all right, well, that's okay. These still cancel out, and these little triangles still cancel out. This was 12.5, and that was 4. But if we're going backwards, this positive is going to be negative. So this is going to be -12.5. And then that -4 was going to be +4. So this is going to be +4. And this comes out to -8.5. I just realized that I made a mistake on that first one, and you guys probably all caught it. Sorry if I confused you. I said the answer was 4, but of course, since it's below the x-axis, it's -4. I apologize for that. And that's it. You are going to have examples where you have circles, and I want to show you a real quick version of what that might look like. So if you have something that has like just a quarter circle that looks like this, and you need to find the integral of that function from 0 to 3, well, here's our quarter circle. All you need to know about this is that it is, or all you need to know is its radius. So the quarter of that this is going to be 1/4 pi r squared. The radius of this whole thing, if it had been a whole circle, is that 3. I know my circle is pretty terrible, but the radius of that is 3. So the area that I shaded in is 1/4 pi times 3 squared. This comes out to 9/4 pi, or 2.25 pi. And just as a reminder, if something with a pi at the end, you can leave the pi at the end. It won't be a like term with anything else, but that's fine. You'll just leave it like this. So here it is. So again, what we were doing was we were finding integrals with areas that needed to be calculated.